Welcome everyone. Thank you for joining us for today's TASI webinar, Turkish Association for Seismic Isolation webinar. My name is Mehmet Emre Özcanlı, and I'm the president of TASI. In TASI webinar series, worldwide reputed seismic isolation experts present on seismic isolation applications in their countries. Today, we are presenting Esquake Seismic Isolator test laboratory in Turkey. Analytical and experimental studies presented by Prof.Dr. Gökhan Özdemir. If you have any questions during the presentation, please type them into the question box in our TASI YouTube channel chat panel. I'll bring them up during the presentation, and we will also have time for questions at the end. Especially, I would like to thank Mr. Paolo Clemente, who is Assisi President, as he distributed our webinar announcement to all Assisi members throughout the world. Dr. Gökhan Özdemir, our presenter today, is a professor at Eskişehir Technical University and the director of Esquake Seismic Isolator Test Laboratory. He has received his BSc degree from Gazi University, MSc and PhD degrees from Middle East Technical University. Dr. Özdemir has also conducted postdoctoral studies at State University of New York at Buffalo. He has authored several scientific publications, and specifically, his research area is focused on dynamic performance of both seismic isolated structures and isolators. Now, I would like to give the stage to Professor Dr. Gökhan Özdemir.
Thank you, Mr. Özcan, for your nice presentation. Today, I will be talking about the Seismic Isolator Test Laboratory facilitated in Turkey, specifically Eskişehir. But before, I would like to give my appreciation to Turkish Association for Seismic Isolation for giving me this opportunity and make me a part of these series that you will come up with further presentations. So I think I can share my screen. Is it okay for you? Okay, then I will share my presentation and start within a few seconds. Okay, I think everything's all set. Okay. As Mr. Özcan introduced, today's topic is the Esquake Seismic Isolator Test Laboratory, and we will be talking about the analytical and experimental studies that we have performed in our facility. This is the outline of the presentation. For the sake of completeness, I just start with the comparison between a conventional design and the seismic isolated structure design. And then I will briefly touch to the seismic isolator types, which are rubber bearings and friction pendulum. Then the next topic will be the isolator tests, why we have performed these tests, and what we have obtained from a dynamic test conducted with these bearings. I will be presenting about some results. And then, of course, today's topic is the Esquake Seismic Isolator Test Laboratory. I would like to introduce a little bit in detail about the laboratory, and then give some representative test videos that we performed in our laboratory for the projects, especially hospital projects in our country. And finally, very briefly, I just try to give some notion about the analytical tools that will be, or that can be used to idealize the real, actual hysteretic representation for the isolators. So let me first start with a conventional design. What we have done in a design is just to start with a design spectrum, and based on this spectrum, we will compute the earthquake forces that will act on the structure. And once you determine the earthquake force and apply to the floor levels, which we assume to be, okay, based on these external forces, we try to analyze the structure and get the internal forces, such as the shear force and the moment diagram that will be used to design the frame members. When we say design, of course, we should understand the dimensioning of the structural frame members. And of course, we should keep in mind that not only the internal forces, but also the deflection or the deformation of the frame has to be considered in the design. It can be drift ratio, or it can be top floor displacement. And of course, what we do is to control the displacement or the deformation of the frame member. And based on this figure on bottom, we can compare the results or conduct a performance-based design for the structure. Okay, as we can understand from this figure, in a conventional design, we are familiar with the deformation in the structure. So it will not be elastic and there will be damage in the structure. And the level of the damage is based on the designer. It can be life safety or it can be collapse prevention, but anyways, there will be a damage in the structure. But if you consider the seismic isolation, the difference in between is that, as I already talked about, in a conventional design structure, we expect the damage in the superstructure. And the damage is due to the relative motion or relative deformation in between story levels. But on the other hand, in a seismically isolated structure, the deformation or the non-linearity is solely focused on just one level, and that level is the seismic isolation level. Means the energy dissipation is performed by the isolators, and the superstructure will move like a rigid body, and there won't be any relative deformation between story levels. So means there won't be any damage in the superstructure. It behaves linearly. So as we can understand, apart from the conventional design structure, there won't be any damage in the superstructure, and we can keep it using as its functionality will be preserved even after the a super big earthquake, which is called as maximum considered earthquake in the design of a seismically isolated structures. And of course, I have to mention that here in the bottom of the superstructure, we have some structural members called as seismic isolators, which is shown by a circle at the bottom of the superstructure. That isolator, what an isolator provides is that during the shaking of the ground, instead of the superstructure, just the isolators will deform because they have high flexibility in comparison to the frame members. So the deformation or the motion will take place at this level, and the energy dissipation will be due to the hysteretic behavior of the isolators. So what I can tell you is that we have basically two types of isolators, and one is the rubber-based, the other one is the friction-based or sliders. In this figure, and on the top left, we have a rubber bearing, which is denoted as the low damping rubber bearing. it is composed of alternate layers of rubber and steel through the height of the bearing, and the rubber is essentially responsible for the isolation period of the flexibility of the bearing, whereas the steel shims or the steel plates will provide a large or high vertical stiffness, and a low damping rubber bearing will provide almost an elastic behavior. And in this case, the needed high energy dissipation or the effective damping ratio will not be enough in case of a large seismicity. And on the other hand, the primitive version of a friction pendulum is this single pendulum, which means that there is only one surface that will be designed to deform during an earthquake. So this kind of bearings will update it with time, and the updated version of these bearings can be a lead rubber bearing and a double pendulum. In a lead rubber bearing, since in the design we need larger dissipated energy or hysteretic dissipation, to provide this, in a low damping rubber bearing, we put a lead plug inside the bearing through the center line, and that lead plug provides additional hysteretic energy dissipation. And this means that what we expect from a seismically isolated structure is about 30% effective damping during a maximum concentrated earthquake. So apart from the low damping one, here you can easily perform or obtain a large hysteretic curve, a large area, and that large area means actually the large energy dissipation capacity. On the other hand, in a double friction pendulum, the updating of these single pendulum is actually not due to the hysteretic behavior, but to small or to reduce the dimension of the isolator. Here, in this case, in a double friction pendulum, there are two surfaces that will act through the cyclic motion. Means that the same displacement capacity will be provided by a very small, let's say, half the dimension of a single pendulum. This provides a very economical design for the same amplitude of motion. And further improvements in these bearings will be the high damping rubber bearing and the triple friction pendulum. In a high damping rubber bearing, we don't need to use a lead core plug or lead core through the height of the isolator, but instead you can improve the chemical mixture of the rubber so that you can have very similar hysteretic behavior or energy dissipation capacity with that of the lead rubber bearing. And besides, in a triple friction pendulum, as we can understand from the name, there are three surfaces that will initiate it during a hysteretic motion or an earthquake. But the point here is there are three specific levels that will be initiated through the motion. Let's say the inner part of this triple friction pendulum will act only at the surface level loading, whereas the upper mounting plate will deform during a design level earthquake, and in a maximum earthquake, then the bottom plate friction surface will be initiated. And I will have to compare the hysteretic behavior of these friction pendulum isolators For instance, the left-hand side graphic will be representative of a single pendulum or a double pendulum, whereas the right-hand side graphic is representative of the triple friction pendulum. As you can see, there is a differentiation between these two, and it is basically the response of the three different friction surfaces in this case. Well, as a designer, what we need to do is to test these bearings and obtain the hysteretic response so that we can perform our design accordingly. And to do that, of course, we have to consider some test facilities, and these test facilities should have or must have large loading capacities, because that much of isolators will be tested very high, under very high speed and very large deformation, and also the vertical force that will act on these bearings will be higher, because that vertical load is actually the function of the weight of the superstructure. So nowadays we will have very large structures constructed with seismic isolation. So this is why we have demanding capacities for these tests. So what kind of test, isolator test, needs to be performed will be the next question. Basically, there are two categories in this group. The one is the prototype test, and the other one is the quality control or production control tests. In a prototype test, as we can understand, we perform these tests to check whether the manufactured bearing sustains the appropriate characteristics, and they are in accordance with the design properties. For instance, in such loadings, in such tests, we need to, or we have to consider three different parameters. One is the effect of displacement, which is related to seismicity level, and the other one is the effect of frequency. Again, the loading speed will be investigated, and the response modification due to that frequency will be denoted. And then effect of vertical force, of course, it is to be noted during the cyclic motion, because in a ground motion, in addition to the two horizontal components of a ground motion, we also have the vertical one, and the depending on the significance of that vertical component, there can be various or difference in the axial forces acting on this isolator. So basically, we perform these prototype tests in order to understand the characteristics of the isolator in the first place. So we check whether these isolators are appropriate for the construction to be used in the construction site or not. And if it is okay, then the next step will be the production control tests. As we can understand from the name of these tests, it is actually a part of quality control during the manufacturing process, and it is performed to understand whether these bearings are very similar or carries the similar characteristics, and to check whether these characteristics change within a small range of variation. We perform these quality control tests. And another difference in between is that prototype a bearing which is submitted to prototype tests will not be used in the construction site, because we apply a very large, a very demanding protocol, and after that we can even damage the isolator, so it will not be used in the construction site. So after that introduction, as we can understand, it is time to talk about the isolator tests. And a few years ago, we have constructed and initiated a construction due to the seismically isolated hospital buildings in Turkey. And even if we have very large projects, we didn't have any facility in Turkey that is capable of performing both the production control and the prototype testings. Instead, we demandingly ask for the facilities around the worldwide countries, let's say United States of America, Italy, China, Taiwan, and so on. But in 2018, we successfully initiated the Esquake Seismic Isolator laboratory in Turkey, and especially in Eskişehir, which is a city in between Ankara and Istanbul. Here we have Eskişehir, as you can see. And I would like to show a map from our campus in Eskişehir. And here we are, the facilities, the Seismic Isolator Test Laboratory, Esquake, is constructed here in the site. And if we have foreign audiences here, I have to say that we have a spatial airport here. International flight is also available, but in the summertime, it is very easy to fly from foreign countries to Eskişehir by plane. I would like to say this. And then I will jump to the laboratory. Here you have the physical view of the laboratory. The plan dimensions of this facility is 25 meters by 40 meters, about 1,000 meters square. We have actually two parts in this building, the office part and the test facility. And the main components of this testing facility is, or the capacity of the testing rig is 20,000 kilonewtons in the vertical direction, which is static. And if we have to perform a dynamic loading, that vertical force will be 15,000 kilonewtons. And the horizontal maximum force is 2,000 kilonewtons, whereas the stroke is plus and minus 600 millimeters. And the maximum loading velocity is 1,000 millimeters per second. Of course, this is dependent of the displacement and the frequency of the loading. Okay, once I inform about the capacity of the laboratory, the next step will be the test rig. Here we have pictures from all angles of the laboratory, from sides, from top, in order to introduce it very well for the audience. And we have two pistons, dynamic pistons, in both horizontal and vertical directions. And vertical direction, we simulate the weight of the superstructure or the force transferred to the isolator through the columns and beams. Okay, and the horizontal piston or the actuator is used to apply the cyclic motion that will be used to idealize the cyclic motion during an earthquake. And of course, we have a very large amount of energy or capacity to apply that much of loading. And to do that, we have these accumulator sets, which are used to energy, to apply energy for transferring the oil from one side to the servo-controlled actuators to apply the needed motion. And what I especially would like to talk about is that we also have an air-conditioned room within the facility, and that air-conditioned room can reduce the temperature or drops down to minus 40 degrees Celsius, and the maximum temperature is 50 degrees Celsius, so that we can perform very demanding tests. And based on this capacity, we can apply loading at different environmental conditions. Okay, another point is that we have a meeting room in the laboratory, because all of these tests will be performed during the visiting of the designer, the constructor, the manufacturer, whatever, okay? All these people will be present in the tests. And in another point is that I have to say, due to COVID-19 nowadays, we cannot accept anyone to visit our laboratory. So we have to present a way for the visitors without coming to the laboratory. So these two screens on the picture are actually used to perform the camera views, video camera view with online connection to the interested people. Okay. The next will be the introduction of the personal quality, or the stuff we use to perform these tests. Okay, as a director, myself will be here, and also we have technical staff and engineering staff. These people are working on the laboratory for full time, and Esquake Çavdar and Volkan Karuk are the civil engineering part of the laboratory. They are also having PhD, especially on the behavior of isolated structures. And Mustafa Keçeci is the electrical engineer, who is responsible for the facility. And then the technical staff, they are responsible for all the things performed in the laboratory, the mounting of the isolators or the bearings to the test rig, and then acceptance or whatever you understand from the test is under their responsibility. So I would like to thank all of these special personnel, especially I have to thank them. Okay, then the next will be the quality of the tests we performed are actually another thing here. You can test anything, but you have to be sure from the results, and the way to be sure about the test result is to use calibrated loading setup. And here we have the certificate of calibrations for both the force and displacement transducers in the vertical and horizontal directions. And I have to say that all the equipment we are using in the laboratory is denoted as class 1, which means the recorded data as the differentiation between the recorded and the applied loading is less than 1%. Okay, and then I would like to talk about the projects that we are involved. We have tested the bearings used in these projects. They're not all the projects we are involved, but just try to select some representative ones. For instance, here I can say Indonesia, Mexico, Philippines, Colombia, and Bulgaria. We have tested all the bearings used in projects, And also we have tested bearings used in Chile, Peru, Armenia, Israel, so on. So this is the reason why I'm showing this projects is that we perform tests not only in Turkey, but also throughout the world. So we have good and this test stuff, okay? Some national projects also here. These are the examples. They are mostly the hospital projects. Kütahya Hospital, Hatay 4 Yol Hospital, Yalova, Malatya, Bilecik, and it goes on. So there are some feature projects also that will be tested in our laboratory, which are Bartın project, also Adıyaman project we have tested very soon. So these are the national projects we are involved in. And let me show you some videos from the tests we have performed in the laboratory. Here, this is used in an international project also. It is a double friction pendulum, articulated one, and it is tested under the displacement of 200 millimeters with a frequency of almost 0.16 hertz. And the vertical force acting on this isolator is 5,000 kilonewtons. Okay, now I will show another one. This is from a national project, and it is one of the biggest displacement capacities we have tested in the laboratory. Here it is 400 millimeters plus and minus, and the frequency is 0.29 with a maximum velocity of, I think, 720 millimeters per second. It is written also here, and the vertical force acting on this bearing was 10,000 kilonewtons. Okay, another one here. This one is actually important because in a prototype testing, we have to perform different kind of loadings. And this one is actually the one with 10 cycles, continuous cycles of loading. This is important because such loading is very demanding. It needs to be use a very large hydraulic power. It is 10 continuous cycles with 118 millimeters with a frequency of almost 0.4 hertz, and the vertical force was 3,200 kilonewtons. I have shown 3 videos which are for friction pendulum, and I think it is time for a rubber bearing. Here it is at 4.5 hertz with a magnitude of 270 millimeters. As you can see, we can perform not only rubber bearings, but also friction pendulum, and the loading capacity is very effectively used in such loading cases. And once you perform the loading, what you have is the report. Of course, this is important for the designers, and what is written in a report is to point out or show the designer the design values of this isolator. For instance, in this isolator test report, here you have the number of cycles, the amplitude, the frequency, and the vertical force. Okay, this picture provides you the resultant hysteretic behavior obtained from the test result. Okay, for each cycle of the motion, in this case specifically we have 3 cycles. So in each cycle we have to present the corresponding force displacement curve so that the designer can judge whether the variation between cycle to cycle is appropriate for the designer or not. And to judgment will be based on the evaluation of the post-yield stiffness, which is denoted by Kp in this slide, and the effective stiffness, which is represented by blue dashed line in the graphs, and of course the effective damping of the isolators. Since it is a friction pendulum, we have to provide also the effective friction coefficient. And one point I have to underline is that during the test protocol, we apply a vertical force, which is in this case 10,000 kilonewton. It has to be almost constant through the testing, because if you're not capable of keeping this vertical force, constant or almost constant, then the response will be something different. Because if your vertical actuator is not responds dynamically, it is not possible to keep this vertical force constant. As you can see, we also provide the vertical force variation during the horizontal loading so that the designer can judge whether the obtained results are appropriate or not. Okay, then. Once I'm done here with the test results and the loading protocols, I have to say that we have a superior capacity for the tests of the isolators. For instance, I have shown you the environmental or the air-conditioned room we have, and using that air-conditioned room, we have performed some tests also with the lead rubber bearing especially. Here, this video will show you the force displacement results relation recorded after the horizontal loading. This is important because we have kept this bearing at a minus 30 degrees Celsius for 24 hours, and the manufacturer asks for us to compare the results at the room temperature. So let me show you the force displacement curve obtained from the tests of these LRB. By the way, these white points are actually the ice. It is kept in minus 30 degrees Celsius for 24 hours and then tested in the setup. And what is the difference in between? If this test is performed in the laboratory condition, which is actually 23 degrees Celsius, and if you compare with the one obtained for the minus 30 degrees Celsius, you can easily see the difference from this graph. So the characteristic strength of the isolator and also the post-yield stiffness, which is used to compute the isolation period, are totally different from each other. And in design, what we engineers do is to perform a bonding analysis, which are actually the lower bond and the upper bond analysis. They are based on the characteristics modified to represent the most disadvantageous cases. For instance, the lower bond analysis is used to estimate the maximum isolator displacement, whereas the upper bond characteristics used to estimate the maximum shear force transferred to the superstructure. Okay, this is important because we can also perform such tests, and it is a part of a research program conducted in our laboratory. This is actually the most advantageous part of our facility. We can perform not only the cyclic loads, but also some climatic effects will also be considered in the laboratory. Okay, finally, I will talk about some analytical part of the research conducted in our laboratory. We can perform not only the isolator tests, but also we are capable of modeling these isolators by using some analytical tools. For instance, here the drawing of a large size bearing is given in the picture. It is almost 1 meter in diameter and has a lead core with a diameter of 190 millimeters. And when it is subjected to a cyclic motion given in the picture, it has 0.1 hertz frequency, and the magnitude of the amplitude of the motion is 280 millimeters. And when you apply this loading to the isolator, what is recorded from the test is here, the force displacement. It is almost 800 kilonewtons maximum force is recorded during the test. And when you try to obtain the actual behavior, it is not easy to consider the variation from hysteretic force displacement curve, because the code requirements imply that the bounding analysis will be used by considering a non-deteriorating isolator force deformation curve. But in this case, which is obtained from the actual response or actual test results, it tells us that the bearing, especially the lead rubber bearing, undergoes a deterioration in strength from cycle to cycle. And to do that in an analytical model, it is nowadays available in OpenSeas. You can analytically obtain the real behavior of the isolators. And the basic reason for the deterioration in strength of these isolators is the temperature rise in the lead core. And that temperature rise is used to define the yield strength of lead through the cyclic motion. So you have an initial strength, which is then modified due to the temperature rise recorded in the lead core. And that temperature rise for the specific motion can be up to 60 degrees Celsius, which means almost 30% of the initial strength will be reduced, and the isolator will provide different characteristic strength and also different stiffness, means the energy dissipation properties will not be constant through the motion, but it is also different from each cycle to cycle. Okay, this is the case for the lead rubber bearing. What about a friction pendulum? This can also be analytically modeled, and the hysteretic response can be obtained accurately. For instance, again, we assume a motion with an amplitude of 450 millimeters, which is tested in our laboratory, and the corresponding force displacement curve is obtained as shown here. Here, again, as you realize, the force displacement curve deteriorates from cycle to cycle. This is basically the temperature rise, this time for the friction surface. When the friction material and the steel base moves photon back, then there has to be energy dissipation. And that energy dissipation is due to the temperature rise, and that temperature rise will be again used to model to reduce the friction of coefficient. And if you can do this, what you will have is something like this. As you see, again, we use the analytical tool incorporated to OpenSeas, which is an open source program, structural analysis program. You can perform these analytical representation. And again, you have to be able to consider the change in the friction coefficient. Okay, if you do not consider any change or any deterioration in strength or friction, what you have is this, the red dashed line, no heating case. The friction coefficient is constant through the motion. But if you consider the heating problem or the heating in the friction surface, then you can be able to talk about the reduction in friction coefficient. I show these two cases because we are capable of not only performing tests, but also where we are very strongful in performing analytical analytic performance of the structure when it is seismically isolated by both friction pendulum or lead rubber bearing. And I think this is the final slide I will introduce you, and that concludes my presentation today. I think it is time. I will not, as planned, I will have talk about the laboratory and the analytical investigations within 1 hour. And I think it is time to talk about the questions. Mr. Özcanlı, are you there to conduct the questions?
Yes, I am here. Thank you, Professor Özdemir, for the excellent presentation. We will go ahead and take some time for questions now. Just a reminder, please be sure to type your questions into the question box in your control panel in TASI YouTube channel. Let me check the questions. Up to now, I think until now, no questions.
That is good. So it is crystal clear so that we don't have any questions.
Yes. Maybe I can ask one question to you. Maybe before the webinar, I asked you the same question. When did you decide on this establishing such a laboratory, and why did you establish such a laboratory?
A good question. Actually, my topic in the research topic during my PhD was the performance of seismically isolated structures under the bidirectional effect of ground motions. So I have prepared my work and present to the authorities, and then I jumped back to the postdoctoral research, and in the research I was in a laboratory at New York State University of Buffalo, which is very qualified laboratory. At that laboratory, I have an opportunity to work with Professor Michael Constantino, and especially the modeling of isolators. And that research program will actually help me to think about these testing facilities and the modeling of isolators. And when I turned back to Turkey at 2010, even we don't have any construction regulation related to seismic isolated structures. I try to get connections with some researchers and authorities to settle down this facility, which will be used in the future. Then within 3 years, the health ministry came out of nothing. They have initiated such a regulation, and by the time there's a huge need for testing of isolators. So from that time, the authorities that I have connected with, which is also one of the authorities is the Turkish Association for Seismic Isolation. I asked for the some letters that tells us it is a big need for the Turkey having such a test facility. So this is the starting point of this facility, and we have initiated the construction of the site of the building at 2015, and within 3 years we have established all the stuff and started to test the first isolator. And I remember that the first isolator we have tested in the facility is manufactured to be used in an international project, and the manufacturer is also a foreign country. Okay.
Thank you for the answer. Also, congratulations. Muhammad, also now it looks like we have a few questions. Muhammad Shukri Yavaş asks, in real applications, upper and lower bonds subjected from these tests, right? Is he asked like that? In real, yes.
Actually, the upper bond and the lower bond characteristics are used or computed by means of the nominal properties. The nominal means the average. For instance, let's say about the stiffness. If you have 3 cycles of motion, from each cycle you will have different stiffness values, and the average of these stiffness will be the nominal stiffness of the isolator. And that nominal characteristic will be used to define the lower and upper bond properties. For instance, if you have performed for instance, the low temperature test, if you have such a data as a manufacturer, then you can give the related lambda factor, which is the modification factor for the characteristic of the isolator. You can use such data from the manufacturer and multiply the nominal value. If you don't, if the manufacturer will not be able to provide these lambda factor, then our OK code will guide you to use a value, a proper value for the required manufacturing process. So yes, you can use the nominal properties to obtain the lower and upper bond characteristics.
And also another question, Farzat Hezaji asks, thanks for your excellent and interesting presentation. Is there any possibility request for conducting tests from other countries?
From other countries, you mean as a foreigner you can test in our laboratory? Yes.
I think so.
Yes, because we already did this for several projects, foreign manufacturers and foreign projects.
Also, another question from Ian Aiken from USA. Thank you very much for the presentation about your laboratory. Also, he asks, Ian Aiken, as you mentioned, the vertical load control is very important for dynamic testing of pendulum bearings. What is the vertical actuator maximum velocity capability?
Slightly larger than 120 millimeters per second.
Ümit Özkan asks, after a cyclic test, do you inspect if the inner sliding pack of a friction pendulum always recenters or not? Have you observed ejection of sliding material?
Actually, we did not perform any triple friction pendulum, if the question is related to that, because as far as I know, the triple friction pendulum is not tested any other laboratory except the production, the facility of the EPS.
I think not friction, triple friction. If the inner sliding puck, he says, after a cyclic test, do you inspect if the inner sliding puck of a friction pendulum always recenters or not? I think.
Yes, okay, I can tell you that it always recenters because we perform displacement control tests.
That's why.
Yeah.
Okay, another question, Ian Icon asks, do you determine the vertical and horizontal forces from load cells or from hydraulic pressure transducers?
From the hydraulic transducers.
Okay. Are there any questions? I think no questions. It looks like we have covered all of our questions. Is there anything else you wanted to cover before a wrap up, Professor Özdemir?
Actually, I have to say that it is my honor to be here because the Turkish Association for Seismic Isolation did a very good job for presenting such a series about the seismic isolated structures. So that's my honor to be here, and I will be sure that the upcoming seminar series will also be very interesting for the audiences, and I suggest all the audiences to be a part of this webinar. Thank you again.
I think, okay, another question from Ian Icon also.
Okay, Ian.
Sorry, because he warned me. Looks like the lower platen of the machine moves on linear roller bearings. How do you estimate the friction losses in these bearings? And does it vary with vertical load?
Yes, it varies with the vertical load, with the speed of the loading in the horizontal direction. It is a very big, complicated problem, actually. We have done lots of tests and try to obtain such friction that needs to be reduced from the recorded data. And that linear bearings are actually THK, and from THK, we get some special help about this topic. This is what I can tell.
And also another one from Ibrahim Kaya. Have you ever tested hydraulic damper at this laboratory?
Actually, we wish to test, but for the time being, there isn't any project in Turkey that asks for the testing of isolators. Actually, we have contacted with you, Mr. Önzandi, about the damper that needs to be testing, but I think it is not available for that time. But we wish to test in the future.
Also, Ümit Özkan, have you ever tested a rotated pendulum, as these are very sensitive to rotation? Rotated pendulum.
What do you mean by rotated pendulum?
I think if you put rotated means elevated plate you can put under the pendulum.
Okay, not for a friction pendulum, but pot bearing was tested with that kind of let's say rotated plate. I don't think that it is the correct form of the version, but yes, we have tested for pot bearings.
And also another question, the vertical is... Yes, Ozhan Alperen. Firstly, many thanks for your work and well-prepared presentation. Could you please tell us some about the fire resistance of the isolators, especially the rubber isolator?
That is a good question, but I don't think that it is a problem when you use the isolators at the bottom level of the structure, because it is away from any kind of danger, fire danger, but still the rubber coating is also used to protect the isolator, for instance, the steel and the lead core from the excessive fire temperature. This is what I know for the timing, but I know that there are some, very few, but some research output regarding the fire resistance of the isolators. I suggest to look for that research output.
Also, Emrah Sarıtaş asks, thank you, Dr. Özdemir, for such a great presentation. How many numbers of isolators can be tested per month, considering Turkish seismic code procedure?
You mean prototype test or production control test? I can give the answer.
He didn't say what. I don't. Maybe we can say prototype.
Okay, let's say prototype test. Again, it depends on which code you are using.
He asks about TSC, I think Turkish seismic code.
Okay, for Turkish code, we have, I think, 21 loading cases, right? And that 21 loading cases will be performed within a day in the laboratory. Or if you're not supposed to wait between each loading cases, which means you can apply the loading without any initiation, a time lag between each loading. So you can perform even 2 isolator prototype tests in a day in our laboratory. On the other hand, for a production control test, again, it depends on the loading, especially the vertical load, because in a production control test, you first apply the vertical load and keep that load for, say, 10 to 30 minutes. It depends on the demand of the manufacturer. So roughly say 10 production control tests in a day, but can be even less or more depending on the isolator test protocol.
And also another question, Yen Icon asks, do you determine the vertical, sorry, I asked it already. Yen Icon, are you able to modify the test machine configuration to test dampers?
Yes, we can, yes, we can, but it needs some operation on the test setup, because the current form, as you can see from this picture also, is not suitable for insertion of a damper to the test machine. But we can find a way, a solution, so that we can directly apply the load to the damper without this using these linear friction rollers.
And also Ümit Özkan added explanation because he asks questions. By saying rotated, I mean that the sliding plates are not parallel to each other. He asked about did you test rotated?
No, not specifically. That kind of bearings are tested in our laboratory.
I think that's all. I'm checking. And Yen Icon, our thanks from the US to Tasi and Professor Özdemir, he says.
I'd like to thank him for this, for his quite well questions. Thank you, Ian.
Then great. Thank you, everyone. We appreciate you being here. We will continue our webinar series. Therefore, please follow our social media accounts for our next webinars. Thanks again for joining us today, and we will see you next time. Thank you, Professor Özdemir.
You're welcome. Bye.
Bye.